Okay, so press record. We're recording now. And start sharing your screen. And I can't do it fast. It always takes a few moments to get that set up. All right. All right, so on the schedule for today, I was going to finish up 2.4, let's do some more problems that are similar to yesterday, and then maybe get started with 3.1. Okay. Okay, so reminder, our first test is this Thursday. Again, so for tests, you may have one cheat sheet, a formula sheet, which looks just like this, 8.5 by 11. Put anything you want on it, but after that, you can't have any other help. You can't ask me for help. You can't ask Star or Mackenzie for help during the test. You can't look on the internet. You can't use your book. You can't use your notes. Okay. As I said before, you have to turn in your homework. So turn all of this in on Thursday. And again, one little double check that I do is I already have a sample of your handwriting from your previous quizzes, right? So I look at the writing. You must turn in the homework. If you don't submit at least 70% of the homework on the test day, I don't accept your test. I will not grade it. Okay, so it's due half an hour after class ends. So again, the class ends for us at 1 o'clock. I'll close the class as normal on Thursday at 1 o'clock. You have 5 minutes to take a picture on your cell phone. You already know what it's about because you've already done it twice with quizzes. Click, 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 click. And same thing for the homework. I'll give you another half an hour, so until 1:30 to submit the homework. But if you want to submit the homework early, that's fine. So after class tomorrow, I'll take it anytime from then until Thursday at 1:30. Okay. Again, a little safeguard for me is you have to submit the homework, and I'll look at your handwriting on the homework and the test. Again, I'm not a handwriting expert, but I already have samples of your quizzes, right? And then I look at the homework, look at the exams, and if I see it doesn't match, say, hey, whoever wrote this homework isn't the same as the person who wrote the test, and it doesn't match the quizzes, then I get very, very suspicious, right? Okay. And so again, my strategy is, okay, I suppose you can get somebody that might want to cheat for you on the test, but you're much less likely to get somebody who wants to do all of the homework for you, right? Okay, so that's that. All right, so we were doing some more inequalities. I'll knock off inequalities, and then we'll get started in chapter 3. So anything I do today and tomorrow on chapter 3 will not be on this test. It'll be on the next test. But just for the sake of having all the exams on Thursdays, I'm not going to stop. I'll just keep going and get started with chapter 3. Okay. So what are you responsible for? How do I study for the test? Everything here. Okay. So what's a study guide for the test? Everything here. Okay. We have there. Okay. And I know Star and Mackenzie have reached out to you about possible, study sessions or whatever. Feel free to use them as help. And that's what they're there for. Okay. So Star and Mackenzie can help you for the test on Thursday. So, and of course, you can come see me during office hours also. Okay. All right. So let's get back to where we were. So we did some inequalities, and I'll do several more. Some more of these, and then there's some that involve division. The divisions aren't really that much different than the multiplications, but there's a little bit of tricky stuff to it. Okay. Okay, so let me do some of these more here. Some of them are a little bit unusual. I'll do 35, which looks pretty bad because there's so much stuff to it, but it's actually easier than you might think. Okay, so let me try that. All right, so 35, 2.4. Page 120, I guess. Okay, 35, let me see if I can write it down. X minus 3 squared. X plus 1 to the 4th power. Two x plus 1 to the 4th power. Three x plus 2 less than or equal to 0. Okay, and let me double check that I wrote it correctly. I think we're good. All right, so my boundary numbers, again, are whatever makes this 0, this 0, this 0, this 0. This one is 3. This one is -1. This one, you have to solve 2x plus 1 equals 0. It turns out to be -1/2. I'll save time and you just trust that that's it. You do want to get some proficiency in doing this somewhat quickly. If I set that equal to 0, I subtract 2, divide 3, it'll be -2/3, right? So here's what I have. Okay. So I put these down on my number line. So again, set that equal to 0, set that equal to 0. These you can probably in your head. This one, you want to get some proficiency even with negatives and fractions. Subtract 1, divide 2, -1/2. Subtract 2, divide by 3, -2/3. Okay. There we go. It looks like it's going to be pretty bad, but it's actually not as bad as you might think. Okay, -1, -2, -3, 1, 2, 3. There's 3, -1. Okay, -1/2, -2/3. -2/3 is smaller than -1/2. Actually, kind of hard to cram this in there. And I also have -1 and a +3. Okay, this is -0.5. This is -0.6 repeating. Okay, so I have this real funny picture here. I have 1, 2, 3, 4, 5 regions this time. 1, 2, 3, 4, and 5. One, 2, 3, 4, 5. All right, it looks pretty bad, but I'll show you it's actually not so bad. Okay, region 1, -2. Region 2, let's see, it's something between -1 and -2/3, which is -0.6. So how about -0.7? Then region 3, something between -0.5 and -0.6 repeating. That's -0.6. Region 4, 0. And region 5, how about 4? Okay, I'm going to raise it up again for focusing. Okay, now I plug into here, 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 and here, but watch this. This is blah, blah, blah squared. That's always going to be positive, right? Likewise, if I raise a number to the 4th power, that's going to be positive. That's going to be positive. That's always going to be positive. That's always going to be positive. That's always going to be positive. The sign is completely determined by this thing. So plus, 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 plus. Automatically, they're positive. I don't even have to plug in, right? So as long as I don't plug in 3, which I'm not, and not plugging in -1 here and so on, these are all going to be positive because I have a square, 4th power, and 4th power. The only thing that's in doubt is that last one, 3x plus 2. Okay, so plug in -2. 3 times -2 is -6, plus 2 is a negative. So 3 positives and a negative makes the whole thing negative. Negative less than or equal to 0, that's true. Region 1. Region 2, -0.7. 3 times -0.7 is -2.1. -2.1 plus 2 is still negative. So that makes that negative, and that makes that true. Oh, I'm sorry, I forgot to shade all these in. It's less than or equal to, so all of these get colored in. All the boundaries work. Okay, and yeah, region 2, that tiny little region there, that also works. Okay, negative 0.6. 3 times negative 0.6, negative 1.8. Add 2, that's positive. So 4 positives, positive, positive less than or equal to 0, no, that's false. 0. 0 plus 2, positive, positive, false. And finally 4. 3 times 4 plus 2, that's definitely positive, positive, false. So I have this weird situation. Okay. True, true, nothing in region 3, nothing in region 4, nothing in region 5, and I have 2 independent dots here, which I can't write as intervals, but just as single points. Okay. So the solution set is parenthesis negative infinity up to here. So where was here? That was negative 2/3, wasn't it? Yeah. I include negative 2/3. Union a single number, negative 1/2. Union 3. Okay, so these are braces. It's not an interval. The braces are to indicate a set of numbers. Again, a quick double check if you have to type this in on an in-class assignment. Yes, the braces are above the brackets on most keyboards, or on my keyboard, look at where the letter P is, right? So look at P. Immediately to the left of that, I see a bracket and a brace. And then to the right of that is a right bracket and brace. So it looks like you have to hit capital for the bracket, and you'll see the brace, the left brace and the right brace. Okay. So again, the letter P on my keyboard, next to it are bracket and brace, the left side, and then after that is bracket and brace on the right side. Okay. So again, this we know what that means. That's an interval. These are just individual points, negative 1/2 and 3. Okay, so that's the way that one goes. And show you that. Okay, so a little bit unusual. All right. Next one I want to show you is something weird like 39. Nine x minus 4 minus x squared, x minus 4 less than 0. Okay, there's a common factor of x minus 4, right? So factor out x minus 4, and I have 9 minus x squared. Okay. So again, the concept is these two are common factors. Pull it out of 9 minus x squared. And that can factor as a difference of 2 squares, right? So x minus 4, 3 plus x, 3 minus x, less than 0. Okay, so we got it completely factored now. And we're ready for the boundaries. This one doesn't look too bad. Okay, so what makes this 0? 4. What makes that 0? Negative 3. What makes this 0? Positive 3. Okay, and less than, they're all going to be open circles. Okay, I got to go out to 4. 1, 2, 3, 4. There's 3, there's 4. And I need a negative 3 also. Open, open, open. Okay, the logic is if I were to plug in 4, right? Put 4 here, here, and here. Well, 4 minus 4 is 0. So when you multiply by that, it's still going to be 0. It'll say 0 is less than 0. That's false. So it stays open. Same logic if I plug in negative 3, that one's going to be 0. If I plug in positive 3, that one's going to be 0, which means when you multiply it out, you get 0 less than 0. That's false, so they stay open. Okay. If I had the line underneath it, if it said less than or equal to, all 3 of these would be closed up. Okay, region 1, 2, 3, 4. 1, 2, 3, 4. Okay, pick something here, 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 and here. Okay, over here, how about negative 4? Region 2, 0. Region 3, well, 3.5. And region 4, 5. You could say 6, 8, 30, but I like that better. Okay, plug in, just give me the sign. Negative 4. Negative 4 minus 4, negative. 3 plus a negative 4. 3 plus a negative 4. Whoops, sorry. Yeah, 3 plus negative 4 is a negative. 3 minus a negative 4. That's the same as 3 plus 4. Positive. So what's a negative times a positive? Positive. Positive less than 0? False. 0. 0 minus 4, negative. 3 plus 0, positive. 3 minus 0, positive. So 1 negative and 2 positives gives me a negative. Is a negative less than 0? That's true. So region 2. 3.5. You can tell we really don't want the exact value with 3.5. Too messy, right? Just need the sign. 3.5 minus 4, negative. 3 plus 3.5, positive. 3 minus 3.5, negative. So 2 negatives and a positive leaves me with a positive. Positive less than 0, false. 5. 5 minus 4, positive. 3 plus 5, positive. 3 minus 5, negative. So 2 positives and negative leaves me with a negative. Negative less than 0, true. All right, so parenthesis, negative 3, comma 3, paren, union 4, comma infinity. Okay, remember to type infinity on the keyboard, type 00, and negative infinity is negative 00, right? All right, so that takes care of these. And now we have some division problems. Division is not that much different from multiplication. Okay, so the rest of the problems, 43 to 57, we have division. Okay, so let me show you how to do some division ones. There is something a little bit tricky about it, though. So how about I start off with 43? X minus 1 over x plus 1. That's going to equal to 0. So you have a numerator and a denominator. This time for the boundaries, set both the numerator and the denominator equal to 0. Set both top and bottom equal to 0. Set both the numerator equal to 0 and the denominator equal to 0. So look at the numerator. What makes this expression 0? 1. And then also look at the bottom. What makes the bottom 0? Negative 1. So just so you know what I did, that's for the top and that's for the bottom. Okay, so if they give me a fraction and I'm comparing with 0, either less than or greater than or less than equal to, greater than equal to, okay, set the numerator and denominator equal to 0. So my boundaries are going to be 1 and -1. Okay, then you pretty much do the same thing. Now, here's something that's a little bit different. Okay, when it was all multiplication, you can pretty much take it to the bank. It's always going to be all closed, or it's always going to be all open. Okay, so it's a close, 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 or open, open, open. Okay, when there's a division, it's a little bit trickier. So why? Okay, let's try. If I plug in -1, -1 there, -1 there. -1 plus 1 is 0. I'd be dividing by 0. That's never allowed. So it stays open. However, I'm going to close up 1. Because if I plug in 1 here and here, I get 1 minus 1 is 0 divided by 2. What's 0 divided by 2? 0. And 0 is less than or equal to 0. So here's our first case where one of them might be open, one of them might be closed. Okay. When you have these all multiplication, it's set. The boundaries are all going to be closed or all going to be open. You have to be a little bit more careful when you have a division. Okay. Again, the denominator is not allowed to be 0, so -1 is no good, but +1 is good. So that's a little bit tricky. Okay. Other than that, same thing. Pick something here, here, and here. So region 1, -2. Region 2, 0. Region 3, how about 2? And this time, there's a division, so I'm going to put a fraction bar, fraction bar, fraction bar, fraction bar. So these are fraction bars. And I'm plugging them to here. Okay, so let's plug in -2 minus 1 is a negative number. -2 plus 1 is also a negative number. Okay, so I'm going to have a negative divided by negative, which is positive. And is a positive less than or equal to 0? No, that's false. So do not shade in region 1. Okay, 0. 0 minus 1, negative, divided by 0 plus 1, positive. So what's a negative divided by a positive? Negative. Is a negative less than or equal to 0? Yes, that's true. And 2. 2 minus 1, positive, divided by 2 plus 1, positive. Positive divided by positive, positive. Is it positive less than or equal to 0? No, that's false. So I only have region 2, which I can write as bracket -1, comma 1. I'm sorry, parenthesis -1, comma 1 bracket. So this means don't count -1. Doesn't work. 1 counts, it does work, and then everything in between. Okay, so that's what happens when you have division. Now they're all not that easy. Let me do some that are harder. Okay, now, the right-hand side is supposed to be 0. If it's 1, then you have to make it a 0, right? So I'll show you how to do that. Okay, so first, how about let me do something like, how about 51? X over x plus 1 is greater than 1. X over x plus 1 is greater than 1. Okay, so see how 43, 45, 47, they all have 0? So 51, they don't have a 0, they got a 1. Move the 1 over so that becomes a 0. So subtract 1. And yes, I'm writing it like this for a funny reason. Okay, I need to get a common denominator. So common denominator, x plus 1, x plus 1, like that, right? So this becomes x minus 1 over x plus 1 is greater than 0. Like that. X minus parentheses x plus 1, so x minus x. Oh, these cancel out, right? All right, so that doesn't look that bad. Okay, so boundaries. Set both the top and the bottom equal to 0. Well, the top is already -1. It's not going to be 0. So how do I make the bottom 0? How about -1? So x equals -1 is my boundary. That's my only boundary. Does -1 work? No. You can tell if I plug in -1, again, you're dividing by 0, so no good. All right, so this is not that bad. There's only 2 regions, region 1, region 2. So region 1, how about -2? Region 2, how about 0? Fraction bar, fraction bar. Now take a look. The numerator is already -1. No matter what I plug in, it's still -1. So negative, right? -1 doesn't change. I'm not plugging anything there. So the top is always negative. So I just plug in the bottom. -2. -2 plus 1. -1 or negative. Negative divided by negative, positive. Positive greater than 0? Yes, true. Zero. 0 plus 1 is 1. That's positive. Negative divided by positive. Negative. Is a negative greater than 0? No. False. So that's it. So what I'm going to put, negative infinity to -1 parentheses. And that's my answer. Okay. All right, so that's how division works. I'll just do a couple more and maybe that'll be it for this part. Okay, 53 looks a little bit harder. 1 over x, 1 over x plus 1. Okay, so remember, I don't want this to be something like that. I want it to be 0. So I have to force this to be 0. Now you can move this one over. Now, if you're copying exactly what I'm having, leave a gap like this. Okay, so I subtracted 1 over x minus 1 over x plus 1. Now, why I leave a space here and here? I need to get a common denominator. So this side needs x plus 1 over x plus 1. This side needs x over x. Right? Common denominator. So x times x plus 1. So the numerator becomes x plus 1. I mean, 1 times that is that. 1 times x is just that. So minus x. And the numerator is just going to be 1, right? Well, that's nice. All right, so again, for boundaries, I said both the top and the bottom equal to 0. The top can't be 0. So I just set the bottom equal to 0. That'd be 0 and -1, right? So x equals 0 and -1 are my boundary numbers. 0, -1. And in each case, it's going to be open, right? Because if I plug in -1 here and here, -1 plus 1 is 0. I'm divided by 0. Mathematical no-no. Likewise, plug in 0. That's a 0. Divided by 0. Mathematical no-no. So just leave them open. And I have regions 1, 2, and 3. So region 1, how about -2? Region 2, -0.5. Or you can say -0.5. Region 3, 1. Okay. Fraction bar, fraction bar, fraction bar. In this case, the numerator is always 1. Sorry, that's not a negative symbol. That's a stray mark. I'll make it into a plus there. The numerator is always positive. It's 1. Positive, positive, positive. So the sign is completely determined by the denominator. Okay, -2 is negative. -2 plus 1 is negative. So positive divided by negative times negative, that makes the whole thing positive. And I'm looking for less than or equal to 0. Positive is not less than or equal to 0. That's false. Okay, -0.5. -0.5, negative. -0.5 plus 1, positive. Positive divided by negative times positive, that makes the whole thing negative. Is a negative less than or equal to 0? That's true. So region 2. And finally, region 3, 1, 1, 1, positive, positive. They're all positive. 3 positives makes it positive. Positive less than or equal to 0. That's false. So again, I only have that. Parentheses, -1, 0, paren. And there we go. All right. And finally, I'll do 59. Have to do some factoring first. And that'll be it. So we'll break after 59. X squared minus x minus 2 divided by x squared minus 3x plus 2 greater than 0. So we can't make heads or tails out of this until we factor. So let's factor. Okay. X, 2, 1, minus plus. Should be plus, sorry. Okay, the bottom, x minus 1, x minus 2. All right, at first glance, you might want to cancel these out. You can't, because x equals 2 is not allowed here. But if I cancel these two guys out, right, x equals 2 is allowed. So unfortunately, I have to leave them both. So again, don't cancel these out. If you cancel them out and you look at the expression, you might say, oh, x, I can plug in x equals 2. But this is the true expression. You're not allowed to plug in x equals 2. So unfortunately, I have to leave it. Okay. But when I plug in, I'll get the same thing here as here. So that'll be nice at least. Okay, so boundaries. Set both the top and the bottom equal to 0. So 2, -1, and 1. And yeah, I don't have to say 2 twice. Okay, so what makes the top 0? 2 and -1. What makes the bottom 0? 1 and 2, but I already got the 2, so I don't have to put it twice. Okay, so it looks like it's going to be 4 regions. One, 2, and -1. -1, 1, 2, open. And here, all of these are going to be open, not only because there's no line underneath it, but you also know you're not going to divide by 0. So these are all open. Okay, if you're not sure, okay, plug in 2 is not even allowed. -1, if I plug -1, that makes this 0. 0 divided by that is 0. It'll say 0 is greater than 0. That's false. That's a 0 there. And if I plug in 1, that's not allowed here. Okay, so they're all open. Okay, region 1, 2, 3, and 4. Okay, region 1, 2, 3, 4. -2, 0, 1.5, and 3. Fraction bar, fraction bar, fraction bar, fraction bar. Okay, so I have to plug in here, 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 and here. But at least whatever you plug in here is the same as this, right? So these are going to match. That's going to match that. All right, -2 minus 2, negative, which means automatically that's negative. Agree? -2 minus 2, I just did it, -2 minus 2. -2 plus 1, negative. -2 minus 1, negative. I have 4 negatives. So what happens when you have 4 negatives and you're multiplying and dividing them? Positive. Let's see, positive greater than 0, that's true. Okay, 0. 0 minus 2, negative, which automatically makes that negative, right? Right, everybody see I can just copy that one and that one because it's the same expression, right? So whatever I put here, I just put there. 0 plus 1, positive. 0 minus 1, negative. So it looks like I have 3 negatives. So if you multiply and divide 3 negatives, you're left with a negative. Is a negative greater than 0? That's false. So don't shade in region 2. 1.5. 1.5 minus 2, negative, which means this is automatically negative. 1.5 plus 1, positive. 1.5 minus 1, positive. So what do I have? 2 negatives. Positive. Positive greater than 0? That's true. And finally, region 4, 3. 3 minus 2, positive, which again automatically makes that one positive because they're the same thing. 3 plus 1, positive. 3 minus 1, positive. 4 positives. Positive, positive greater than 0, true. Okay, 3 regions. Negative infinity, -1, parentheses, union 1, 2, union 2 to infinity. So looks like I have all of this. And yeah, you can remember if I give you something like this on the in-class assignment, you can type parentheses, brackets, and braces. We now know how to do braces, right? We had a braces one. And union is just U, and bracket brace, yeah. And infinity is OO, negative infinity is negative OO. So yeah, you know how to do all that. Okay, I'm done with the section, folks. So if you have any quick questions, you can unmute yourself or put it in the chat. Otherwise, we'll break shortly. But I am now officially done with material that you need to know for the first test. Okay, so we will break. After the break, I'll start chapter 3. Anything I say from here on until tomorrow will not be on the test. The test will just cover all of this. Okay, and actually what I'm trying to do is this. If you think you might have questions on the test for tomorrow, okay, now of course you can talk to Star or Mackenzie if you wish, but if you want to bring up stuff in class, I'll try to leave you some time. That's why I only had 3.2 here. If you want to have maybe the second half of class, if you want to have a question and answer session, we can do that. And likewise for Thursday. Okay, Thursday, if you have questions at the beginning, I'll let you ask them, but if not, I can just give you more time for the exam, okay? So that's what's going to happen. So after the break, I'll get started with 3.2 material. Okay, so let me stop the share. Anybody have a question? You can put it in the chat or unmute yourself, otherwise we'll break. Okay, seeing nothing, then I guess we'll go straight to break. Okay, let's see, I have 11:54-ish now. So let's start about 12:05 again. Okay, so break until 12:05, and I will disappear also. Okay, folks, we're going to start up again. And go back to sharing the screen. All right. So chapter 3, we're back to doing something called functions. You might recall we did functions in intermediate algebra, hopefully. No matter anything I'm doing now will not be on the test, so I'm just getting ahead. So go ahead and take notes if you wish, but look at it kind of half-heartedly, I suppose. Wait until after the test on Thursday to, focus in on the chapter. But a review of functions. Okay. So let me show you what we're up against. Page 130. Definition of a function. A function from set A to set B is a rule that assigns to each element in A exactly one element in B. Okay, so one input can come back with only one output. You don't get two outputs for a function. Right. We're going to be doing a lot of work on the domain of a function. Page 132. The domain is a set of all possible x values or input values. Okay, so why can't I just plug in anything? Well, you might be limited. If there's a square root for real numbers, I can't take the square root of a negative, so that's part of the game. And if there's a fraction, we already said you can't divide by 0. There's some other more complicated things, but we'll get that later when we get to trig and logs. There's some other funny things that we have to watch out for the domain. But for now, mostly if it's algebraic, square roots, I can't take the square root of a negative. Keep that in mind. And if I have a fraction somewhere, we know that we're not allowed to divide by 0. Okay. And you might recall functional notation. Okay, functional notation, we usually write something like f of x, function of x, f of x, g of x, h of x. They all mean functions. As far as you're concerned, it's just like the letter y, like these. Y equals blah, blah, blah. Okay. The first problem is we're just determining the domain. And by the way, so domain is a set of input values, set of x values. Some of the problems later ask for the domain and the range. We're not going to worry about the range. So skip range. Range is a set of possible y values. Okay, so I'm going to write that down right now. So for a function, I'll make my own abbreviation real quickly. 1x gives 1y. So an x cannot go to two different y values. 1x gives you only 1y. The domain of a function is a set of x values. And the range is a set of y values. For a function, 1x can give you only 1y. Domain, set of x values. Range, set of y values. Okay. In some problems, it's very hard to determine the range, so we're just going to go with the domain. So the first problem is just ask for the domain. And we recall when I write something like this, this is read f of x. It's a function of x. So this does not mean f times x anymore. It's not multiplication. F stands for function. Function of x. Okay. So when we write stuff like f of x, g of x, h of x, it's just like y. But they're also telling you, hey, this is a function. Okay, 1x can give me only one y value. Okay. You don't have to pick y. It looks like they picked s or some other letter, but that's okay. All right, so I'm gonna get you started on some problems involving the domain. How do I find the domain? Whoops, looks like I accidentally lost. There we go. All right, so what are we doing? 9 to 23, 29 to 37. Okay, so first problems involve domain. So let's try some of these. How about I'll do number 9 in its entirety, A, B, C, D. So page 138, section 3.1. Y equals negative 5x plus 1. You can put anything you want. Big, small, fraction, decimal, positive, negative, 0. Okay, so the domain, I'll abbreviate domain with D. If we know we're talking about the domain, I'll use D. Is all real numbers. One way you can write all real numbers is the funny looking R. Okay. Another way you can write all real numbers is negative infinity to infinity. You're going all the way out to the left and you're going all the way out to the right, but this is a little bit shorter. Okay, so that's hopefully straightforward. What if it's written like this though? Y equals 1 over negative 5x plus 1. Okay, now I'm not allowed to divide by 0, right? So I need to find out what value makes the denominator 0 and throw it out of my domain. So negative 5x plus 1 equals 0. Move over the 1. Negative 5x equals negative 1. Divide by negative 5 means x equals 1/5. Okay, so if I plug in 1/5, I get 0. So that's a no-no, but any other real number would work. So what do I write for the domain? The set of all real numbers minus the set consisting of 1/5. Okay. Now there's other ways to write it, but I think this is the easiest. It's all real numbers except for 1/5. Okay, 1/5 isn't going to work because if I plug in 1/5, I'm going to divide by 0. But other than that, any number will work. Okay, then C, they give me a square root. Square root of negative 5x plus 1. Cover it up. All right, so behind my ruler here, square root. I can only take the square root of non-negative values. Non-negative means positive or 0. I can take the square root of 0. Square root of 0 is 0. And I can take the square root of any positive, but no negatives. So whatever's behind my ruler here must be greater than or equal to 0. So negative 5x plus 1 greater than or equal to 0, and then I solve that. Okay, algebra is sort of similar to this. Subtract 1. Divide by negative 5. But a little bit of a trap. Do you remember what happens if I divide by a negative? Inequality symbol reverses. X is less than or equal to 1/5, like that. Okay. So 1/5 is something like that. Shade everything here. So that means I'm allowed to plug in 1/5. If I plug in 1/5, I would get 0. But I'm not allowed to plug in any number bigger than 1/5, like 1. 1's not allowed, right? Negative 5 times 1 is negative 5 plus 1 is negative 4. You'll be taking the square root of a negative. But anything smaller than 1/5 would work. 0 is okay. 0 plus 1, yeah, that works. Okay, so how do I write this? This will be parentheses, negative infinity, comma, 1/5. I'm including 1/5, so bracket like that. Okay. Now D, they have a cube root. Cube root. Can I take the cube root of a negative number? Yes, we can. It's negative. So it doesn't matter if behind my ruler is a positive or a negative or 0, it's going to work. I can take the cube root of anything. So the domain is, again, all real numbers. Okay. All right. That's how that one goes. The next one I want to show you is a little bit harder. 15. 15a. A, B, and C. F of x is x minus 2 over 2x plus 6. X plus 6. All right. Well, we already know we're not allowed to divide by 0. So I set the denominator equal to 0. Okay. I'm just going to go straight to the answer. I'm trying to push you a little bit for this. You subtract 6, divide 2. I trust you can figure that out. Right. Now, if you want to go slower and go minus 6, that's okay. But I'm supposed to push you a little bit for this. You have a negative 6 here, right? And then you divide by 2, x equals negative 3. So that actually gets thrown out of my domain. That's sort of like this other one here. So the domain is all real numbers minus braces, the set consisting of negative 3, like that. You just punch a hole at negative 3. Okay, negative 3 is not going to be allowed. Okay. And then I'll come back to B. Let me do C first, which has a cube root. I'm going to do C. Let's see where to go. H of x. All right, cube root. Well, from what we just said, if I have a cube root, if all of this comes out to be a negative, I'm good. If it's 0, it's good. If it's positive, it's good. So the only trouble, again, is what makes the denominator 0. So in many respects, this problem is just like the previous one. Okay. All real numbers minus the set consisting of negative 3. We just did it. No need reinventing the wheel. Okay. Can you take in a cube root? You can take a cube root of positive, negative, and 0. So that's not an issue. I just have to make sure I'm not dividing by 0. That would be the case if I plugged in negative 3, right? So that's the same. So the answer to A and B are both the same. The domain is all real numbers minus the set consisting of negative 3. Okay, just think of the whole real number line and just punch a hole at negative 3, throw out negative 3. Okay, the harder one is B because it's a square root. So square root 15b, g of x, square root of x minus 2 over 2x plus 6. That's a little different. cover it up. Sometimes I say, if you don't like looking at it, don't look at it. Okay, so behind my ruler has to be what kind of a number? Greater than or equal to 0. So that stuff greater than or equal to 0. Because it's a square root. And if you stop and think about it, we just did that before the break, right? That's exactly the kind of stuff we did before the break. So it's a nice reinforcement. So technically, even though this is, a new chapter and it's not going to be covered on a test, well, this is covered on a test because we just did this kind of problem, right? All right, so what makes the top 0? 2. What makes the bottom 0? We just did it, -3. Those are my boundaries, right? So in some sense, even though we're doing a new chapter, we're still kind of reviewing for the test, as it were. 1, 2, 3, 1, 2, 3. Okay, -3 is like there. 2 is there. And here's another case where 1 is open and 1's closed. What happens when I plug in 2? 2 minus 2 is 0. 0 divided by that is 0. It'll say 0 is greater than or equal to 0. That's true. And what about -3? If I plug in -3, 2 times -3 is -6. -6 plus 6 is 0. I'm dividing by 0. That's a mathematical no-no. So this one is closed. This one is open. 1, 2, 3. 1, 2, 3. Okay, how about -4? 0, 3. Region 1, region 2, region 3. Fraction bar, fraction bar, fraction bar. -4 minus 2, negative. 2 times -4 is -8. -8 plus 6 is -2. Negative. Negative divided by negative, positive. Positive greater than or equal to 0, true. Shade that in. Region 2, 0. 0 minus 2, negative. 2 times 0, 0, plus 6, positive. Negative divided by positive, negative. Is a negative greater than or equal to 0? No, that's false. So do not shade in region 2. Region 3, 3. And by the way, you can see the reason why I said 3 twice, but one is a region 3 and one's a number 3. So if I wrote this the regular way, like the regular 1, 2, 3, then you say, oh, do you mean the region 3 or the number 3? But if I put Roman numerals, then you know for sure that's the region 3. This is the actual number 3. Is that right? That's the reason why you change it to Roman numerals so you don't have the confusion. Okay, let's see. 3 minus 2, positive. 2 times 3 plus 6 is positive. Positive divided by positive, positive. Positive greater than or equal to 0, that's true. All right. So the domain is -infinity, -3, parenthesis, union, bracket, because I'm including the 2, 2 comma infinity, and infinity and negative infinity always use parentheses. Okay, so parenthesis here, not included, bracket here, included. Okay. All right. All right, so that's how you do those kind of problems. Okay, then fairly rapidly through some of them, some other domain ones. What do we have here? 9 to 23. I'll just quickly say 17 and 19, polynomials, linear, that's all real numbers, right? You can put any real number for 17, 19, any real number, you can cube it, you can multiply it by 4, you can take away 5. So 17 and 19 are all real numbers. 21, 23, you do have to watch out for fractions. Okay, I'll do 23b because that's a little bit weird. It's x cubed minus 5 on the bottom. Okay, I'll do 23b and then some more work with functions. (23b) f of x x cubed plus 3, x cubed minus 5. All right, I'm not worried about the top. The top can be anything, doesn't bother me, even 0. I just have to set the denominator equal to 0 and throw that out of my domain. So I solve x cubed minus 5 equals 0. Okay, solve. Add 5. Now, if you're copying what I'm doing, leave a little gap here. Can you guess why I want to put a gap here? How do I change x cubed to just x? In other words, how do I get rid of a cube? Cube root. That means you go like this. And when you do a cube root, you don't need a plus or minus. No plus or minus necessary. So x equals the cube root of 5. It's not a nice number. It's irrational. Okay. The concept is the number, I'm guessing it's 1 point something, times itself gives me 5. Okay, so how do I write the domain? All real numbers minus the set consisting of the cube root of 5. Okay, so if I plug in a cube root of 5 here and here, well, here's no problem, but cube root of 5, cube, by definition, is 5. And then 5 minus 5 is 0. I'll be dividing by 0. Okay, but any other number should be fine. Okay. Okay, and so we, quote unquote, only have 29 to 37 odd, but it's not as short as you might think. I'll just show you 29. 29 has A, B, C, D, E, F, G, H, I, J. So that's what, 12 questions? 12 questions within one question. So it's not as short as you might think. Okay, so yeah, I'll do some of these from 29. Okay. I'm almost done. Even if I don't finish, that's okay. I can do some more tomorrow. Okay, x squared minus 3x plus 1. All right, so they give us A, B, C, D, E, F, G, H, I, J, K, L. I'll do some of them, at least one of each different type, I guess. So A says f of 1. Plug in 1. 1 squared minus 3 times 1 plus 1. 1 minus 3 plus 1, negative 1. Okay, no big deal. What might be a big deal is a fraction, D. F of 3 halves. 3 halves squared minus 3 times 3 halves plus 1. So I can tell I'm not going to like this so much after all. I'm guessing you probably don't like it either because of the fractions. So put 3 over 2 here in parentheses and here. Okay, what's 3 over 2 times itself? 9 over 4 minus 9 over 2 plus 1 over 1. Common denominator is 4. So times 2 times 2 times 4 times 4. Is that right? So that's going to be 9 minus 18 plus 4, whatever that is. So let's see, 13, negative 5/4. Okay, and again, I'll raise it up again for focusing purposes. So of course, you can watch the video later if you want. Okay. E. F of Z. F of Z. So how do I do that? Well, I just substitute in Z. In fact, it's easy. Just put a Z there and a Z there. Z squared minus 3Z plus 1. That's all. Okay. Harder is an expression like F. F of X plus 1. This is going to be a little bit harder. So that means pretend you erase that X, put parentheses X plus 1. Erase that X, put parentheses X plus 1. So it's like this, parentheses X plus 1 squared minus 3 parentheses X plus 1 plus 1, like that. Okay. It's the same concept, just more complicated. So one more time, erase that X, put X plus 1 in parentheses, erase that X, X plus 1 in parentheses. Okay, now we just clean up that algebra. X plus 1 squared, shortcut is X squared plus 2X plus 1. And then minus 3X minus 3 plus 1. So distribute, distribute, clean it up. So that's going to be X squared. And that's going to be 2X minus 3X, right? So minus X. And 1 minus 3 plus 1 is a negative 1. So X squared minus X minus 1. So that's how to do that one. Okay, one more of that type that's a little bit weird is J, F of radical 3. Well, put radical 3 right there and right there. Radical 3 squared minus 3 radical 3 plus 1. Well, what's radical 3 squared? 3. And then I got 3 plus 1 is 4. So 4 minus 3 radical 3. And that's my answer. Okay, so some of it gets a little bit weird, but hopefully you're able to follow that. Okay, I'll get started with maybe just another one and then I'll stop. What time is it? 12:35? Yeah, I want to leave enough time to do one of the in-class assignments. So yeah, so if I don't finish, I'm okay. So I guess you can say technically I would end up being a little bit behind, but I'm pretty sure I can catch up tomorrow anyway. And don't forget, we still have all, I have all these extra days at the end. So I may, quote unquote, fall behind a little bit, not quite finishing 3.1, but that's all right. Okay. So how about I show you sum of 31, and then I'll stop. 31, f of x is 3x squared. And 31 has a, b, c, d, e, f. So let me do some of those for you. So how about B? It says f of x squared so whatever's behind my pen goes right there. Erase that x, put this thing and square it. So the skeleton, so to speak, is 3 blah, blah, blah squared, right? That's what it's going to be. So if behind my pen was a 4, you put a 4 right there, right? If it was a 20, you put a 20. If it's a W, you put a W. If it's x squared, I put x squared. And what is x squared squared? X to the 4th. Okay. I'm sorry, that wasn't B. That was C. Went out of order there. Sorry. C. That's letter C. Now I was going to do B. 2f of x. 2f of x just means take 2 times this. 6x squared. That's all there is to it. Maybe I'll do a harder one. D, f of x squared. Well, I square this. 3x squared squared. 3x squared times 3x squared. 3 times 3 is 9. X squared times x squared, we just did that. X to the 4th. All right, then E and F, and then I'm done. E looks like this. F looks like this. F of x over 2, f of x divided by 2, like that. So they don't mean the same thing. Let me get this one out of the way. This says, just take the original, divided by 2. Like that. This one is sort of like this one over here. Whatever is behind my pen goes right here in parentheses. So again, I start off with the same game as this. It's a skeleton. I put 3 parentheses squared, right? 3 parentheses squared. Whatever's behind my pen goes right here. If it's a 1, I put a 1. If it's a million, I put a million. If it's at pi, I put a pi. So what is it? X over 2. Okay, so now I have x over 2 squared. X over 2 times x over 2. X times x is x squared. 2 times 2 is 4. So 3x squared over 4. And there we go. All right, I'm done, folks. So I'm going to give you a problem to do in class. I don't see anything in the chat, so I think we can just go straight to it. All right, so right now, you can take a picture on your cell phone if you wish. I'm going to write the problem out that I want you to solve. You can, on your own piece of paper, do the work, and you can draw a number line, but you can't really draw a number line when you do this. So just write the answer in interval notation, okay? So this is what I want you to solve. Okay, x minus 4, x plus 2 greater than or equal to 0. Okay, so write your answer in interval notation. Take a picture on your cell phone now, or do a screenshot, or write the problem down real quickly. I'll make it disappear in about 15 seconds. So your answer in the private chat, put just the interval notation. And you know how to write infinity. you know how to write negative infinity. You should know how to write brackets and parentheses. Okay, I will give you a hint that all of those are involved in this problem. Let me think. Yeah, if you do it the right way, there's going to be a negative infinity for this one. There's going to be a positive infinity. There's going to be brackets. There's going to be parentheses. Okay, so work that out. If you have a question, put it in the chat, and either Star or I will help you. And when you're done, you may leave. Okay. I'll assume you all have it now, but maybe I'll even type it in the chat also for you. So parentheses x minus 4, x plus 2 greater than or equal to 0. Okay. Solve it. Again, when you turn something in like this on a test, show your work. Quiz, show your work. Homework, show your work. Just not here because it's too hard to type it and show your work. Okay, I'm going to make this disappear. And go ahead and work on it, but I think I'll also type it in the chat. Okay, I will stop recording also. So recording will